In this section, we're going to look at restrictions on variables. Now, first off, I guess have an understanding of what we mean by restrictions. So, the restrictions here are values that the variable cannot have. We're used to restrictions every day. You can't drive until you get a permit. That's a restriction, right? Things that you cannot do. So there's some things that you can and cannot do with radicals. And largely it will depend on whether the radical has an even exponent or, well, in this case is a 1 there, but an odd exponent. The explanation for this goes easier if we start with the even exponents. So let's talk about restrictions on this side. All these exponents here, or powers, are even. 2, 4, 6, 8. Okay, so how do you take the square root of x squared? Well, what had to multiply twice to give you x squared? That's the question. That's what root x squared means. Okay, well, x times x, both with an exponent of 1, would multiply to give you x squared. You would add your powers, 1 plus 1, 2. So what is the square root of x squared? Well, it is x. And x is a variable. Is there any number that x could not be? And in this case, let's think positive and negative numbers. So if you had the square root of, let's use a positive 2. Can you do this? Well, you could square a 2 and you would get 4. Square root of 4 is 2. Alright, so a positive number seems to work. Let's try a negative. So let's make it a negative 2 squared. Well, we get 4. Not a negative 4, we get 4. Because a negative 2 times a negative 2, that's what squaring means. So you're doing a negative 2 times a negative 2. Negative times negative is positive. Well, you're back to this step. You just get a 2. Square root of 4 is 2. So from this, we would call this a very simple proof. And I'll use that word loosely when I say proof. We'll do more in mathematical proofs a little later. So this is a very general proof. So we're just using an example to go through. So there's no restriction on the number you put in here. All right. So you could have a positive or a negative. Let's try it here. Because this proof works only for this example. All right. So let's clean this up. Okay. So 1 multiplies the square root of x to the power 4. Well, 1 multiplied twice to give you x to the power 4. So something had to add, the same number had to add to give you 4. Well, 2. All right. So that had to be x squared. So you see the trend here? X squared was x. X to the power 4 is x to the 2. So we're just taking half of this. So let's ignore the 8 here for a second. And I'm getting ahead of myself. I'd have to come back to this one. So the square root of x to the 6 is x to the 3. Right? X to the 3 times x to the 3. You would add your powers or exponents and you would get a 6. So the 8 in front here, so let's bring that back. Can't just do that with every math question, that would make it easy. So what's the square root of 8? Well, 8 is 4 times 2, 2 root 2. Hoping by this point you can look at the square root of 8 and think 8 is 4 times 2. Square root of 4 is a 2. Square root of 2 is still just a 2. So that would still be just a 2. Now, we didn't talk about the restriction here for 4. So is there any number that you couldn't have here? Well, let's keep it to positive and negatives. So let's topic restrictions on this one. To the power of 4. And since we're just starting with positive and negatives, let's just use negative symbol. Square root of a negative is put to the power of 4. Now, when I'm thinking about this power of 4, I'm thinking a negative multiplied 4 times. So a negative times a negative is a positive. All right? Times another negative. Positive times a negative would give me a negative. Times another negative, give me a positive. Or, there's a neater way of looking at this. Negative times a negative is a positive. Let's look at the last two. Negative times negative is a positive. Positive times positive is a positive. And so this would mean, can you do the square root of a positive number? Well, yes, that would work out. Then if you had, positive 2 to the power of 4, that's 2 times 2, 4, times 2 times 2. Well, that'd be 16. 4. You can do that. So a positive number would work. And a negative number would work because positives don't change anything, and negatives would work. And you'll find that this would be the same going down through here. That anytime you have, and here's the part I want you to listen to, anytime you have an even power, so I'm going to say again, an even power, 2, 4, 6, 8, you'll always be able to work the question out, and you can work it out with any number, positive or negative. Always works. So square root of 9 is 3, and square root of x to the power of 8 is half of that, x to the power of 4. So let's talk about where you start running into some problems. You get problems when you start dealing with odd exponents. So over here, even is good. Well, I shouldn't say good and bad, but even works beautifully. Odd can cause you problems if you're not careful. So let's talk about positive and negative numbers, and you choose an actual number. So square root of x. Can't take that any further. X is just x. So can x be any number? That's our question. Can x be anything? Well, let's try the square root of a positive 4. You say, yep, I can do that. X would be 2. So positive 4, so x could be a positive number. We know that would work. Well, what about a negative? What multiplies twice to give you negative 4? You can't say this, 2 times negative 2. It's got to be the same number. Okay, so you say negative 2 times negative 2. Yeah, but that's a 4. So I'm going to ask again, can you do square root of negative 4? Can you do it so that you get one number that multiplies to itself? 2 doesn't work because 2 times 2 is a positive 4. Negative 2 doesn't work because it has to be negative 2 times negative 2. That gives you positive 4. You don't come back with a negative. So this one can be done. So that one cannot be done. Impossible for negative numbers. So the negatives, gotta be careful. Like can't be done. That's what I mean with this x. So yes, no. All right. let's look at trying to simplify here first. So x to the power 3, can you simplify that? Is there anything that multiplies twice to give you x to the power 3? Like the same number that would add to give you 3. Well, and you're not allowed to use decimals or fractions. So there is no single number. But can you give me two numbers that would add to give you 3? Sure. A 1 and a 2. Bases are the same. Here, 1 plus 2, 3. So how you would write this? So this would be written as x to the 1 times x squared. Because you have to think about it, you got to stop your brain for a second from rushing ahead and think. Because what you might think is 1 times 2 is not 3, sir. That's not how this works. The powers add. 1 plus 2. That's 3. That's what you're trying to get. So can you do the square root of x to the power 1? No, that doesn't simplify. That's just root x. There's no two x's that can multiply to give you just x. But can you do square root of x squared? Yeah, we done it over here, and it was just x. All right, so we look here. X to the power of 5. Well, there's no two same numbers, so you can't have the same number to add to give you 5. So you can't have, well, you're going to have this, x times x. But you can't use the same exponent here to add to give you 5. 2 and 2, well, that would give you, well, that would give you a 4, not a 5. You could say 1 and 4. They would add to give you 5. Remember, it's adding. 1 and 4 add to give you 5. Can you do the square root of x to the power 1? The answer is a big no. 1 multiplies twice give you x to the power 4. X squared does. Remember, with the even power, it's always half. Yeah, okay, that works. And here, well, let's deal with 12. 12 should be quick for you folks now. 12 is 4 times 3. Square root of 4 is 2. And be left with a 3 on the inside. Then you have x to the 7. Now, you could write 1 and 6. That would add to give you 7. 1 and 6 to add to give you a 7. You could write 2, 5. That would add to give you a 7. You could write 3 and 4. That adds to give you a 7. So what pair do you use? Use the numbers that have the biggest even number. So 1 and 6. So I always write it with a 1. In other words, make this a 1. And the other number is just going to be 6. So if you had x to the power of 501, that's a big odd number. Well, you would write it as x to the 1 and x to the 500. Can't do the square root of x to the 1. Let me go down here. That's just going to be root x. But x to the 500, well, you always go half. X to the 250. So let's clean this off. So it doesn't matter how big the number is, you're just going to go 1 less. Ooh, got rid of my divider. Just put it back in a different color. All right, so then you got 2. 3x you can't do anything with. X to the 6, half that. X to the 3. And when we're talking about restrictions, what numbers are you not allowed to have underneath the root sign? Well, we already shown up here that negative numbers don't work. So even if we try a negative number here, let's stick with -4. So I'll do this example just with I'll prove this with one example. So if you had 4 to the power 3, then you can work that out. You'd have 4 times 4 times 4, 64. And you square root 64 is 8. I made that look like a 31. Just the 3 thing here. So again, just pick the positive number, 4. 4 to the power 3. 4 times 4 is 16 times 4, 64. That works down to 8. Well, let's pick a negative now. -4 to the power 3. So you're going to have -4 times -4 times -4. So these two give you a positive 16. Oh, but you got to multiply to this -4. So 16 times -4, -64. And that cannot be done. You try that in your calculator, you get an error. It doesn't work out to -8. Because that would mean that -8 times -8 is -64. It doesn't work. So there's a rule here, a summary that I want you to come up with. And I'll ask you in class what it is. But can you summarize by this here? Okay, I'm going to end the video right there. So 5 would be in 2 parts. So just the introduction, and then we'll go down to topic restrictions on variables after.